It objectively is. So
Excuse
feel free
me?
to specify.
So you just made a claim that the Earth is planar wherever you drop a plumb, Bob. Do you have measurements that back that up?
That's not what I said. What I said is when you drop the vertical plumb, it's vertical, so it's perpendicular to what?
I don't drop a plumb, Bob. We don't
I
need
know
plumb
you
bobs
don't because
anymore.
you don't do real surveying. What you do is you take the real surveying data, then you go over 12 kilometers, then you invoke geodetic surveying, stitching their data together, presupposing the geoid dimension. Did you not listen to my intro, bro?
Can you show me where I said anything about 12 kilometers?
Well, that's the typical measurement where geodetic surveying begins. Now, you're going to invoke something optically through 200, 300 yards and take an approximation, I would guess. But geodetic surveying is invoked over 12 kilometers. Do I have to cite it?
So I didn't say anything about 12 kilometers. I said that surveyors, even plane surveyors, take elevation corrections due to curvature into account. They use the 8 inches times the mile squared formula.
What was my rebuttal?
Did you have one?
You
didn't have any measurements that.
Elevation relative. You don't even remember my rebuttal.
Well, let's go over it again. What did you say?
Elevations relative to sea level. You're saying sea level's curved. So you're just begging the question. You're begging the question.
So you dispute the textbook that I shared that said the shape of mean sea level is an oblate spheroid.
So you're appealing to a textbook presupposing that the Earth's a ball, which means that sea level would have to be curved, but sea level means level. It's horizontal. You have to assume that it's convex over an orthographic view. So that you're appealing to a textbook, that's your response?
I already showed you that I have backed that up with my own measurements. When I showed you the lighthouses.
Specifically, then I'd love to dismantle them.
Well, I showed that already with the lighthouse observation, that it backs up the textbook. So if you have something, the measurements that you made that dispute the textbook and what I've done, I'd love you to share those now.
Well, yeah, but just a second. Let's just go poke all the holes in your little fake claims, because falsification is independent of replacement, and I just think it's very disingenuous to claim geodetic surveying objectively measures the dimensions of the Earth when it requires dimensions to work around, and everyone knows that. I've read literally thousands of documents about it, so it's laughable that you'll be this disingenuous. So let's stick to your claims. Now, you're claiming that you saw a lighthouse that looked a little bit lower than your level view, right? So what we're using, a theodolite?
I was using a total station.
Okay, so you're using a total station. You establish level relative to your location and your elevation, and you look over a body of water. You see a lighthouse, and it looks below what the horizontal that you established was. And so that means that it must be bending over, down, and away from you on a ball. Is that your claim?
The only way for Seguin Island Lighthouse, the elevation of which is at 184 feet, the light, to be below the crosshairs that were at 7683 feet, is for the surface between us to be curved.
That's patently false. So what happens when you go back the next day? Is that the exact same location?
The next day?
Yeah, or like 365 days in a row. Is it the lighthouse at the same place every day?
No, refraction is a factor.
Exactly.
Which is why we got a radius measurement that was far too large.
Right. So what you're doing, bro, is you're looking through atmospheric conditions over distances, and you're taking the optical resultant or the perception of whatever's there through the atmosphere, and you're trying to correlate that to physical reality by assuming something physical must be. It's literally begging the question. So it'll fluctuate constantly. If I go back the next day, that lighthouse will not look the same way. Objectively.
Did you make that observation? Did you make that observation? Did you go and repeat what I did?
Well, you're invoking it as a positive claim. So would you like to show? You just admitted that it changes. Mm-hmm. What? You just admitted it changes day to day. So
yes, surveyors deal with refraction. Yeah.
Okay, so you knew exactly what the refraction was, and you knew that you compared them day to day and saw the optical effects relative to your perception.
Don't need to.
Don't need to.
What I need from you is I need measurements from you that dispute what I've showed you.
So this took about 5 minutes, and you're already disavowing all of your nonsensical claims that you measured the Earth being a globe. So we can move on to flat Earth evidence now.
I made no nonsensical claims.
Yeah,
what I need from you is I need you to show me measurement data that competes with what I've done, significantly competes.
Yeah, sure. Well, here's what we're doing right now. We're pointing out the fraudulent nature of your claim. You're trying to shift the burden because you don't want to stake your claim. But that's not how this works. That's not how intellectual exchange works. You made a positive claim. I'm so stupid. I'm a flat earth. Your introduction was that flat earthers are stupid. So since we're so stupid and you proved us wrong, how about you substantiate it? How can you know the lighthouse is actually going down over a curve if it changes hour and hour and day to day due to atmospheric conditions?
Well, see, here's the thing. You're saying that my claims are fraudulent, but you have not demonstrated that they're fraudulent because you haven't presented competing measurements.
I'm asking you to specify your own claim prior to me rebutting it with evidence, but you're afraid to stake your claim because you know that it's completely nonsense. Because if you claim, oh, look, this is below my total station horizontal, and look at that means if it's below it, it must be below me. That means the Earth's a ball. But then if you go back the next day, it'll be a little bit higher. If you go back 2 days later, it'll look a little bit lower. If you go back 5 days later, it'll be close to your horizontal. That substantially proves that what you're observing is nothing more than a perception, an optical illusion. It fluctuates based on atmospheric conditions objectively. What you're doing is claiming, well, we're going to take some approximation because it fluctuates, and then we're going to tell you which one we think is closest to what we think it should be. That's literally what you're doing.
So you're saying that surveyors can't use optical equipment to make measurements?
They do use optical equipment, but they do it in very small increments, very controlled, and they establish a plane or a vertical, horizontal, or perpendicular to a plane, and they do it in small increments. Now, if you're going to look out over vast distances over atmospheric conditions and then take a median and claim to know that you know the actual convexity of the terra firma, that is lunacy.
So what you're also missing is that the lighthouse observation agrees with the plumb line's divergence observation measurement.
Okay.
Because they both show the Earth curves.
Let's move to your other claim then. Okay. So you can't answer my refutation of that claim.
You didn't refute it. You had nonsense that you came out
with.
If
it constantly fluctuates, how are you staking a definitive measurement of actual location?
I'm showing that it is below the crosshairs.
If it constantly fluctuates, how can you use that to definitively claim an actual location?
Well, what you need to do is you need to go to that location and see if you can get Seguin Island light above the horizontal crosshairs.
Hey, man, if it constantly fluctuates, how can you claim that to be a definitive measurement of the actual location? Because it's not. It's objectively not. It's the apparent location, right?
But the result is still spherical, and that's what we're here to talk about.
Oh, that's the best you got? Because the result
isn't any measurements that rebut anything I've said, so it's really interesting.
I will actually, yeah. Oh, but we're gonna just point out that you are just making shit up. So, no, we'll move on now. Okay, are you going to respond to my rebuttal then?
You didn't rebut anything.
Yes, I did. I just said, how can you claim? Because what you're claiming is to know that the reason that the lighthouse is lower is because the Earth's a magic spinning cartoon ball brought to us by Jesuit priests with a certain rate of convexity dictated by the radius claim. That's what you're claiming, bro. So that means that lighthouse is being obstructed by physical Earth curvature and is bending down and away from us. That's your claim. Well, if you're going to make a definitive claim about an actual location of convexity, you're going to have to support that with something other than an approximation within a fluctuation of apparent locations. It's dumb.
I see. Well, what you're missing is that observation agrees with the plumb lines. So I still have a spherical object. So we're just talking, is yours spherical or is it flat? So we have a spherical object. And so an object that is taller than my location, more than twice my height, will always be more than twice my height, unless you think that parallel lines actually converge.
Oh my goodness, man. Are you just going to straw man me? So I explained in my intro, the difference in flat Earth and globe Earth is on flat Earth, we go establish a local plumb. And for all practical use, we assume the Earth to be flat. But with the globe Earth, you take our local plumb data, then you bend it, and you say, well, actually, it's going down to the middle of a magic cartoon ball with a core that's somehow magnetic, even though that defies physics. And then we get the angle, then you get the arc length from point to point. You must assume the radius value to even know what the difference is. Now, you're claiming you're looking through the atmosphere at the plumbs you established locally, vertically relative to a horizontal axis, and then you're trying to measure the differentiation and approximation through the atmosphere again, then reverse engineer it, and the best you could do, muddying the waters by messing with your figures like that, was get within 1.4 degrees, because I paid attention in your
I said 1.4 seconds, arc seconds, not degrees. So much tighter than you realize.
Okay, fair enough. Okay, so is it exactly what it's supposed to be?
It's the answer predicted by the National Geodetic Survey was within 1.2 seconds of my final mean that I had.
Oh,
And my margin of error was 1.4 seconds. So the correct answer was within my margin of error. So that means
okay.
I got
What
the
was
right
the
answer.
highest? What was the highest you got?
What was the highest I got? Well, let me go look at that.
Because you need to know the highest and the lowest. Now you're taking the middle mean, which we know you didn't
Means
actually
not the
take on
middle.
average.
Means not the middle. Means not the middle. You
Means
got to
the
get your
average.
mathematical terms right. Yeah.
Median's the middle, means the average. So now that you're getting
It's not the middle, though.
because you're imploding, how about you try and argue what the point is?
Let's see.
Okay, so anyway, you're taking an approximation of an apparent location. You're trying to tell me via reverse engineering based on parameters that you're assuming that you know it's accurate.
I didn't assume anything. I just measured the zenith angle between those 2 points back and forth. I didn't have to assume anything. You just measured.
You use the sun and the apparent location, right? And you the apparent location of the bobs, right?
When I measure reciprocal zenith angles, has nothing to do with the sun.
Okay. And so did you measure the apparent location of the plums?
I don't need plumb bobs to measure reciprocal zenith angles.
So you don't need to establish plumb anywhere in this situation.
See, the total station and the target are both plumbed up.
Right.
On the tripods.
Thank you. I know. So you do have to establish plumb then.
Right, but not with a plumb bob.
It doesn't matter.
Right. I just want to make sure that you understand how surveying works in the modern era.
I think it's weird that you don't.
That's your claim.
Well, I think you do, but I think you're being disingenuous a little bit. So whatever.
That's what you think. But you still have measurements that can be with my measurements.
Specificity then, bro.
Excuse me?
Stop dragging me through the mud. Did you look at the plums, or you determined the relative nature of the plums, right? Because that's what you just said. You just said this literally agrees with me looking at the plums and finding out that they're not parallel. That's what you said. So how did you do that? Cut to the chase. How did you know the plums weren't parallel specifically? Don't just say spherical excess like you're teaching the room. We all know spherical excess is you take a point, you triangulate it, and if it exceeds 180 degrees, that's spherical excess. We know what the principle is. That requires the presupposition of the actual plums being relative to center of mass. I'm asking you, how did you definitively just demonstrate that without presupposing it?
So you missed my opening presentation, obviously.
No,
so if two lines are parallel, to figure out if two lines are parallel, we must connect them with another third line that intersects both of them. And we measure the angles on one side of that intersecting line.
How do you do that?
Well, you set up your total station at one point, plumb it up, and then you set up a target at the other point, plumb that up. You point the total station at the target and read the zenith angle that's on the screen. You do that in both faces, face one, face two, direct and reverse measurements, and you do multiples.
Okay, sorry to interrupt you.
Excuse me?
What distance was this done at?
Well, I've done this with various distances, but the one where I did it I did it four times in one place. It was over 1,500 feet between the 2 points.
You look through 1,500 feet of the atmosphere whenever it's known all across the board. I've talked to dozens of surveyors that you're messing with getting accurate results extending over like 200 yards. You're really not going to get a you went 1,500. Did you say feet? 1,500 feet?
Yes. Yeah.
1,500 feet. So you go 1,500 feet out and you look through the atmosphere. Then you get an approximation of the apparent location, and then you get an average, and then you figure out what you think off from parallel it is, correct?
No, it's not what I think is off of parallel. It's what the measurements show.
The measurements through the atmospheric conditions that are constantly fluctuating, right?
If you want to keep making the argument that surveyors can't measure through the atmosphere, go ahead and keep doing that, because you're going to land yourself in a really ridiculous place.
Straw man fallacy. Cool. Good job, bro. Beat that straw man up. Do you actually know what I said? You even know what I said?
Yeah, you're saying that I can't measure through the atmosphere.
Okay, once again, a straw man. So you have to measure through the atmosphere. It's the only way survey data is compiled. But I said you have to do it within short increments, like maximum 200 yards or so. You just said 1,500 feet, and you admitted that what you do is you look through that 1,500 feet of atmosphere, and then you take the mean of the apparent location, reverse engineering what you think
Nope.
it is. That's what
You've
you
got it all wrong. You got it all wrong. So I point the crosshairs at the center of that target, right?
Mm-hmm.
And then I look down at the screen and it tells me what the zenith angle is. I write the zenith angle down in my field book because I don't want to collect any of this data in a data collector and have it apply curvature corrections after the fact. I need to know what's happening before it does any kind of curvature correction. So that's how this observation works in all the times that I've done it.
I got a question before we go further.
Excuse me. Let me, no, hold on.
Go ahead. Just go ahead.
I'm not guessing where the center of that target is. I'm pointing my crosshairs right at the center, right? And then I flip the scope, turn it around, shoot it in reverse. And then I do it 4 more times. So this is already put through so much rigorous measurement that I'm very certain of where this ends up. That's why the standard deviation of the mean at the end is plus or minus 1.4 seconds, not degrees.
Because it's only 1,500 feet away. So it wouldn't be much off.
Only 1,500 feet away? Oh, okay. So you agree that it's not a very long distance.
Oh, yeah. Keep interrupting me, bro, after I let you monologue bullshit. So it wouldn't be much off if the Earth was a sphere if you're only 1,500 feet away because the radius is 3959. Your angle would barely be off. So what you just admitted, and you don't seem to admit, is that you're measuring such a minute fluctuation through the atmosphere of an apparent location by sitting the center of what you appear to see. You're also admitting to get a mean, it isn't always the same center. You go the next time, you got to move the center down a little bit. Then you're taking the average. And of course, it isn't a big fluctuation because you're only 1,500 feet away. If the Earth was a sphere, it wouldn't be big. So you're just giving us this little bitty minute comparison on a standard of comparison. So to know how accurate something is, you have to have a standard to compare it to. And the standard you're comparing it to is the very thing you're claiming to prove, which is the dimensions of the geoid model. And I said this in my opening.
Yeah, I didn't actually say anything about the geoid model, comparing it to that. So geoids for elevations. Anyway, so what I'm doing is I'm measuring over and over and over. Repeatability is a foundation of good surveying. You seem to be saying, now correct me if I'm wrong, you seem to be saying that doing the same measurement over and over is actually adding error. Is that what you're saying?
Sorry, say again.
So I'm saying that repeatability is the foundation of good surveying. So by measuring this over and over and over and over, I'm saying that's going to get us a better result. You seem to be saying that repeating the measurement over and over is introducing error rather than reducing it.
No, wow, that was so.
I just want to make sure, is that what you're saying? Because I wanted you to clarify.
You're so desperate, man. You're so desperate right now. You're straw manning me. It's intentionally deceptive. It's very
No.
I'm going to actually clarify now, man, because you straw man me. So you establish the local plumb. You drop that vertical, whether you're using a total station or not. The principle's the same, even though you want to divert that too. You drop vertical. That's perpendicular to the surface of the Earth. Assumed to be a plane. You assume your critical starting points or your control points being a plane coordinate system. And then you're going to compile the data under small increments. You're going to repeat it even under small increments. So even at 200 yards, you're going to repeat it more than once to try to make sure you get as accurate as you can. But your plumb is not what you're looking. You established plumb at the beginning. What you're doing is looking at 1,500 feet of atmosphere and trying to tell me by centering it on what is looked at, what you perceive through the atmosphere, which means it's inherently being refracted. You're looking at it, putting a little line on the center of it, moving it up and down as it changes, and then averaging out the zenith angles, and then telling me, oh, it isn't parallel. Bro, what are you talking? You never see the actual plumb. You see the apparent location. How would you know it wasn't parallel? It was assumed to be parallel to even be established locally.
So the answer is in the error analysis, right? So plus or minus 1.4 seconds over four series, 3 days. 5 sets of measurements each time, direct and reverse. That's actually 10 sets of measurements, really, if you think about it, each time through the series from each point. So 20 measurements each time through the series. So what I'm hearing is you saying is, nuh-uh. So what I need from you is I need to see measurements that you've done this and that you have shown that plumb lines are parallel because you seem to think that they are.
Hey, was there ever one of the times that you saw that it did appear to be parallel?
Never once.
Right. Now, do you know what? Now, let's say this. Let's see how honest you are for the whole audience. Okay. So if it was perfectly parallel and you backed up way through the atmosphere, would you ever perceive it to be perfectly parallel?
That's a good question. Well, you have to look at the margin of error of your equipment, right?
The answer is
So
objectively no.
if you came up with 180 degrees and 1 second, and your margin of error was plus or minus 1.5 seconds, then they're probably parallel.
Okay, so let's see if you can answer the question, man. So if it
You
was
did.
actually parallel and I looked through the atmosphere, would it ever appear to be perfectly parallel, even though we knew objectively it was? Would it ever actually appear that way through the atmosphere?
I can't say because I have never encountered that.
Well, refraction's inevitable, right? Because there's no way to remove the atmosphere, which is a contradiction in terms. Because well, there is no sphere and gas has no inherent shape, but whatever. So you
Oh,
can't.
positive claim.
You can't. Yeah, gas doesn't have an inherent shape. Are you challenging that claim?
No, you said something
Yeah, I
about a
wouldn't challenge
sphere,
it
but
either, bro. So stop trying to divert
you
your
said something
pain.
about a sphere, so I just found it amusing.
Yeah, you're spiraling, bro. So anyway, you're looking at the plumb through the atmosphere. All you're getting is the apparent location because of atmospheric conditions are going to refract the image. This is objective, not debatable. You can say you don't know, doesn't matter. So you want to move on to where we measured the Earth to be flat?
You got measurements for me?
Well, yeah, it's very simple measurements. Do you know what the geometric horizon is?
I've heard of it.
Okay, so if the Earth has a radius of 3,959 miles, it's a ball that's bending all around us, right? Because it's a ball. So we know the rate of convexity based on the radius value. Okay, that's where you get your geometric horizon. It's 1.225 times the square root of the observer's height in feet. That's where the geometric horizon should be. It can be closer than that, but it cannot extend further than that because the geometry necessitates that the rate of convexity be below that marker, right? You're following me? So that means at 1 foot, the square root of 1, of course, being 1. If we made an observation at 1 foot, we should be able to see the geometric horizon or Earth curve no further than 1.2 miles away. We have an observation from 1 foot where we see the horizon beyond 10 miles. That would make the radius of the Earth need to be 260,000 miles. That falsifies the claim that it's a physical location like you're trying to claim with your freaking lighthouses through the atmosphere. So we have the only way that survey data is valuable for practical use is assuming plane. And then we have observations that would require the radius value be 260,000. Now, would you just see if you're honest, would your geodetic surveying computations be accurate if your radius value assumption was wrong?
Don't have a radius value assumption.
So how do you know what the angle of plumb is then relative to center of mass?
Don't need to know what the radius is to measure the divergence of plumb lines.
Okay, so you just said that you got within a certain amount of a standard of comparison. What's your standard of comparison if you don't know the radius value?
The National Geodetic Survey. I don't have to have the
use
radius in my head.
value. They use the
I
radius.
don't have to have the radius in my head to make a measurement.
Well, good thing I didn't say that, did I?
Well, I'm just letting you know.
Well, I think everyone knows that you probably don't even know the actual size of the Earth. So, but you measured it though. So anyway,
so you get straw man me and all that other
what's
stuff.
the circumference of the Earth?
It's not really important, is it?
I thought you said that I was straw manning you. So you don't know the size of the Earth. It's all good. So it's 24,901 miles at the circumference, 21,160 nautical miles, 3,959 miles of radius, whatever, it doesn't matter. So whenever you get that radius value, that's how you get what the angle should be relative to center of mass. You, of course, can't get your angle to center of mass without knowing where the center of mass is. So the very survey
Don't have to know that.
Okay, so how do you get your angle to center of mass if you don't know where the center is?
The divergence of plumb lines.
And then you compare that to what?
I don't have to compare it to anything.
Well, that was your whole postulation, was we got within this amount of the standard of comparison.
Right.
That's what you said.
I thought that you'd find that interesting, that an independent check of the divergence of the plumb lines at a particular location was within the margin of error for the
your
predicted
assumed model you're supposedly proving.
It was within a very tight margin of error of the predicted divergence of those plumb lines
based on the model, right?
Based on the WGS 84 ellipsoid.
Yeah.